We propose holistic CMGs, a novel framework designed to tackle a core challenge in co-speech gesture generation, achieving true semantic grounding in holistic full-body movements. Existing frameworks still face several key limitations. Many methods rely on external semantic retrieval or predefined. In addition, flow matching-based models are typically trained only with semantically matched samples. As a result, the model often learns generic rhythmic gestures rather than sparse semantic gestures, such as iconic or metaphoric gestures that convey specific meaning. Furthermore, most methods model body parts in isolation, which makes it difficult to maintain cross-modal consistency and holistic coherence in the generated gestures. We address this by encoding audio and text into a shared semantic latent space. Using contrastive flow matching, the model learns to identify correct alignments while actively diverging from mismatched pairs, ensuring that the generated motion is both rhythmically accurate and semantically grounded. Let's take a closer look at the underlying architecture. In the first stage, we learn a strong motion prior using a residual vector quantized variational autoencoder, RVQVAE, which encodes holistic full-body motion into discrete latents. The second stage consists of two synergistic modules. First is the Semantics-Aware Composite Module, SACM. Unlike prior methods that model body parts in isolation, we treat the body as a composite full-body representation. SACM explicitly shapes motion latents to be congruent with speech semantics by aligning speech-text embeddings with pre-quantized motion latents at the frame level. It uses a contrastive structure pulling matched speech, motion pairs together while pushing apart mismatched, semantically incongruent pairs. Then we have the Multimodal Conditioning Module, powered by Contrastive Flow Matching, CFM. While standard flow matching learns a conditional velocity field that transports noise to the target motion, it does not explicitly teach the model which motions are semantically wrong. Let's look into the detail of CFM. CFM introduces mismatched audio-text conditions as negative context and trains the flow to align with the ground truth trajectory, as well as diverge from trajectories induced by incongruent semantics. This contrastive constraint makes the generation path from noise to motion more directionally stable and improves semantic grounding. To exemplify semantic drift and highlight the effect of our semantic grounding, we provide a qualitative analysis of two representative semantic words that typically correspond to semantic gestures, namely never and because. Case 1. Never. This is a strong negation. Let's look at the ground truth in our model video.
Journalists never tell lies and are always seeking the truth. Journalists never tell lies and are always seeking the truth.
Our model generates clearer negation cues like sharper head shakes or broader sweeping arm motions, so the denial is visually communicated. Then look baseline's videos.
Journalists never tell lies and are always seeking the truth. Journalists never tell lies and are always seeking the truth.
Baselines tend to soften it into mild beats. Case 2, because. These segments carry causal explanation and semantic emphasis. Let's look at the ground truth in our model video.
Because good communication skills are very important when you're doing interviews. Because good communication skills are very important when you're doing interviews.
Our model shows gestures that support reasoning, like open palm offering motion, aligned with both semantic stress and underlying rhythm. Then look baseline's videos.
Because good communication skills are very important when you're doing interviews. Because good communication skills are very important when you're doing interviews.
Baselines often remain uniform across the explanation. While the case studies provide intuitive evidence of improved semantic grounding, we further corroborate these observations with large-scale quantitative results. On both Beat2 and Show datasets, holistic SEMGs consistently and outperforms competitive state-of-the-art baselines, including SemTalk and eMage, across standard metrics such as FGD, beat consistency, and diversity. Finally, we conducted a user study to evaluate human perception. Participants watched videos of a character doing gestures and rated each video on 3 criteria using a 5-point Likert scale. 1. Naturalness. 2. Diversity. And 3. Alignment with speech content and timing. Across all 3 dimensions, participants consistently preferred holistic SEMGs over the baseline models. Our approach outperformed existing models in speech gesture alignment, demonstrating that the resulting motions are better timed and more semantically relevant.